Let's try to understand this problem, which is based on Bohr's theory of hydrogen atom. The problem says that calculate the energy associated with first orbit of helium plus of helium cation, which what is the radius of this orbit? You need to calculate the energy and the radius, the energy and energy associated and the radius of the orbit in which the electron is revolving around the helium nucleus. Okay, Bohr's model, what you can note here is that the Bohr's model of hydrogen atom is also applicable to this species or similar species like helium ion or lithium ion or beryllium ion, beryllium cation or helium cation or lithium cation, provided so that there is one electron in the atom. The excess electrons are removed. So that's why there will be the species will be positive ions. Depending on the number of electrons that are removed, it will be one positive or two positive or three positive ions. So in this particular species where the Bohr's model of hydrogen atom is applicable to calculate the energy and the radius, let's try to have a picture of this. Helium, its atomic number is 2. That means in the nucleus there are 2 protons. And since mass number is 4, this because in addition to two protons, there are 2 neutrons. So total nucleons are 4. So there are 2 neutrons which have no charges, which are neutrally charged, and 2 protons. And since it is a helium positive ion, like a cation, that means although there are two protons and 2 electrons revolving in the first orbit, one electron has been removed, so there is only one electron. So this particular species that is helium ion, helium positive ion, the helium cation, we can use the Bohr's model of hydrogen atom to calculate the energy possessed by this electron and the radius. And what radius? It is moving around the nucleus. The energy of in the nth orbit, maybe first, second, or third, in the n orbit is, since it is in the first orbit, the value of n, that is principal quantum number, will be 1, is given by minus rh z squared divided by n squared. Here rh is the Rydberg constant having value of 2.18 into 10 to the power minus 18 joules. And since this is atomic number, had it been for hydrogen atom, the relationship was simply E nth is equal to minus RH 1 by n square. But for hydrogen-like species, similar species like this one, there's one more variable that is put, the atomic number, because atomic number, because the number of protons in comparison to the hydrogen atom, there is one more additional proton is there. There are 2 protons in helium, 1 in hydrogen. Because of that, there is the energy will be more in case of the hydrogen-like atom or helium ion. So z square, the atomic number is 2, so we put the value of z as 2. 2 square is 4. So 4 into 2 is around 8. It's 8.72 into 10 to the power minus 18 joules. So this particular electron in this helium ion possesses an energy of minus 8.72 into 10 to the power minus 18 joules. Right? The meaning of this negative is like what we are assuming, that when an electron is kept at very far away place at infinity, its energy is assumed to be 0. So when it's brought near the nucleus and it starts revolving around the nucleus, its energy will be less than that. So less than 0 means it will have negative value. That's what the significance of this negative value in calculating the nth energy. The energy of the electron when the principal quantum number is 1, or when revolving in the first first orbit. So this much will be the energy possessed by the electron. What about the radius? The radius Rn is given by a naught multiplied by n square divided by z, where a naught is known as Bohr's orbit. It is a constant. It has a value of 52.9 picometer. And since it is in the first orbit, the principal quantum number is 1, so value of n is replaced by 1, so 1 squared. Z, since the atomic number is 2, is 2. So it doesn't have a, so what we need to do is divide this by 2 is 26.45 picometer. Or when you can convert into nanometer. Nanometer is 10 to the power minus 9, it is 10 to the power minus 15. Accordingly, it will be, if you convert into nanometer, it will be 0.02645 nanometer. That means in case of helium, the electron will revolve slightly closer compared to when it had it been a hydrogen atom, it would have been revolving at 52.9 picometer. But because there is more proton over here, the radius becomes smaller. The electron revolves closer to the nucleus, and the radius is 26.45 picometer. Had it been a simple hydrogen atom, there would have been only one proton in the nucleus, and the radius will be 52.9 picometer. I hope this is clear.